Right guys, good morning. Well, I'm coming back to you with the hope that I'm going to complete my lecture on LinkedList. Of course, yesterday I did not cover much ground because I faced the challenges when I've started making very large files that could not be sent over the app. Well, I hope I've optimized much enough so that I can complete my topic today. Well, we talked about single linked list or single linked list. Some call them single linked list, some call them single with an I, single, some call them single with an E instead of an I there. So the same with double linked list. Some would say double linked list to put an I, of course, making the double there an adjective which describes the linked list. Well, that does not matter to us much because we are not language professionals. Ours is technical business to actually explain how science works. So there we are talking about a double linked list, of course, or double linked list. This is a two-way list that it can traverse in one. A normal linked list, a single linked list, you can traverse through one direction from the beginning of the linked list going to the end. It actually means if you are at the end of a single linked list, you cannot find the other nodes to point back. So it actually means traversal can only take place in one direction in a single linked list. But in a double linked list, we can say when we get to the end, we can start getting back, because at the end we can still find the node. If we have got n nodes, it means if we reach to the final node, which is n, we can still find n minus 1, we can still find n minus 2 going back from the end of the linked list, because we still have pointers that can point back. So you find in a single linked list, pointers are coming from the head, pointing to the next as we go to the end of the linked list. It actually means if we are at the end of the linked list, we cannot traverse back. But look at what is happening now. Look at the node of a double linked list. It is a two-way list, which is a collection of data items that can actually point to the predecessor and to the successor. So it actually means each node has a previous. Look, previous there, and next. Previous is pointing to the predecessor. Next is pointing to the successor. If you remember the terminology that we talked about yesterday, to say these lists have predecessors and successors. So it actually means that only the first node, which is the head node, is the only one that will be having maybe a single pointer, which is pointing to its successor, because it doesn't have a predecessor. Then the last node, of course, it doesn't have a successor, so it actually means it will be pointed to by its predecessor, and therefore it will be having a single pointer, the other one which will be pointing to now, right, to indicate the end of the list. So it actually means the next will always be now for the final node. Right, so look, we have given an example there where we are saying, look at the first node there, where we are saying predecessor is now, and then the data element is 11, and then successor is 200, right? So 200 is at memory location 100, and therefore, the successor there is 20. 20 is at location 100, and it's pointing to its predecessor, which is at location 200, and the successor is on location 400. Look at what is happening there. So our data items are 11, 20, and 40. Then our predecessors are n, 200, and 100. Then our successors are 100, 400, and n. So it actually means that that last node, we are saying that it can't point anyway, so its successor pointer should always be now, right? Then you can look there, the second linked list, where we are now saying we are inserting a new element look at what is happening. When we are inserting a new element, it means we need 4 pointers, right? 2 pointers pointing to and fro the new successor, and to and fro the new predecessor. So we are manipulating 4 pointers there instead of the previous one where we need to manipulate only a single pointer, right? So there we are. Same when we are deleting. It actually means when we are deleting, we are simply making our pointers jump. We make the pointer for the predecessor jump to the next successor but one. Then we make the pointer for the next successor but one previous jump to the previous successor but one, right? So the concept of linked list is always the same. When we are deleting, we make our pointers jump an element, right? And then they point to the next element after the one that we are deleting. So in programming, there's what is called garbage collection. Automatically, when we jump an element and we stop pointing to it is going to be deleted, and therefore memories are memory it was occupying is availed to the operating system for other programs to use. So look, we are now talking about reversing links. We are now talking about reversing links when we want to maybe do reversals in linked list. It actually means when we are doing reversing, we are now trying to say, as we traverse through from the beginning to the end, we are now trying to traverse from the end going back to the beginning. This is the concept of reversal, to mean that pointers will have to change. Of course, merging the list is something very simple there. We are trying to simply say, if we have two linked lists, we are trying to make them into one. When we make them into one, then they are now under a single name of a single linked list, and they can identify each other in terms of the elements that were once in the two linked lists, right? So you can see an example there where we are saying we have the one that is data members being 9, 12, 14, and now. Then the second one now there. Then we are trying to actually make them into a single linked list, right? So what are you seeing there? We are seeing that when we are making a linked list, it actually means that values that are repeating will then be, if we say we have a point that is existing in the first array and we still have that value existing in the second linked list, it actually means we have to take one of those and then we eliminate the other one, to mean that we are not going to allow duplicates in terms of numbers that are the same, right? So now I'm going to talk about sorting in the next presentation. I'm scared that my file might be too large there and it might not fit here. So please let me talk about sorting of a linked list in the next presentation.